So when I look at this, we're trying to find all of the solutions to this equation. So I'm trying to figure out when that left-hand side is equal to 1. And when you look at that, what do you instantly notice? What instantly jumps out to you? What don't you like? What's ugly? What makes this hard? So what I'm hearing is you don't really like the fact that there's multiple things inside of there, right? And that appears in a couple different spots. So if this is our issue, then I'm wondering, is there another way I could write this? And instantly, for me, that jumps out as being one of those, identities. That's an angle sum. So I can use that angle sum idea to rewrite it. And looking forward, that's going to be nice because it's going to give me just cosine of x, and sine of x. And then I'm going to get cosine of pi over 4 and sine of pi over 4. I know that's going to come up. Which that's awesome because I know pi over 4 is an automatic. So this starts to split it. And so if I use one of the identities, I'm going to get cosine of x multiplied by cosine of pi over 4 because it's that coset identity. And then I'm going to have subtract, because it's the whole she hates him thing, sine of x, sine of pi over 4. Right. And then if I did that there, it'd be great if I could do it here. Now, one thing that I do have to be careful of, I took this whole thing, and that's become this whole blue thing. And that's not a big deal there, but when you look at the equation, I'm then subtracting all of this stuff that I make from that second one. So as I start to do this, I'm going to use that identity there as well. I get cosine of x, cosine of pi over 4. And then I'm going to get, that's a subtraction sign inside of there. So I'm going to have plus cosine, or sorry, whoa. I need a bigger eraser. Sine of x, sine of pi over 4. And what I'm subtracting is that whole thing. All that stuff in green is this stuff up here. Why is that going to become really important? That I made sure that I realized I was subtracting that whole thing. Quickly. Why is that big?
Don't lose track of your work.
Maybe, so I don't lose track of my work. Why else? CG? I'm subtracting that one term. Right? And so I have to distribute that negative through. I'm subtracting everything inside of there, and so that's going to become important. And so I have to realize that I'm really subtracting this first piece here, and I'm also subtracting that piece there. And this starts to become really nice. Look at the things that jump out. What I notice is that I have cosine x, cosine pi over 4 here and here. And if you look at it, I'm taking this and I'm subtracting that. I have something subtract itself. Those are just going to cancel out. So then if I write down what I have left, I've got negative sine of x, sine of pi over 4, subtract, bless you, sine of x, sine of pi over 4, and that all equals 1. Wow, and that looks pretty. Because look at it. I really have the same thing twice there. So can't I just write this as, I have negatives. They're both negatives, but I have 2 of them. So 2 of sine of x, sine of pi over 4 equals 1. That's a weird looking 1. Yes, L. Exactly. To be more confusing. So then when we look at it, what still looks ugly, or what's something that we could make prettier? Sine of pi over 4. I know what that is. That's one of my automatics. So I can go ahead and figure out what that is. And sine of pi over 4 I just know is root of 2 over 2. And as soon as I did that, I started to get a little excited because I see that over 2, right? It's divided by 2. But I also see a multiply by 2 on that side. Those things are going to cancel out. It's going to become 2 over 2, right? Multiplying by 2, dividing by 2. There we go. So we've taken that whole thing up at the top, that very ugly statement we had to begin with. And in the end, what we've reduced it to is negative root 2 multiplied by sine of x equals 1. What questions might you have at this point? I'm going to go ahead and erase all this so we can just kind of work with our simpler version, because really all that we did there was we took and just made it prettier. We weren't solving anything. We were just making it, we're simplifying. Because our goal is going to be to simplify before we solve. If we can make it easier on ourselves, it'd be ridiculous not to. And again, sorry about the handwriting. So now I'm looking for x. So I want to solve for x. Looks like I could divide both sides by the root of 2. And actually the negative root of 2. I might as well take care of it all at once. So I'm going to get sine of x equals 1, and it's going to become a negative over root 2. I'm just not going to put that negative in the denominator. I'm just going to say it's going to become a negative quantity. That doesn't look familiar. Sine of x equals negative 1 over root 2. That doesn't look like one of my automatics. So I don't know what angle that's going to be. Yeah, is there another way that I could write that right-hand side? Is there a different way we could view that? And so Paige just said, rationalize that thing, multiply by that fancy 1, and that would give us sine of x equals negative root 2 over 2. Which that is one of my automatics. That's one I already used, right? That's that whole idea that sine of pi over 4 is root 2 over 2. I just have to think about it being negative now. So really, I know that I'm looking, as soon as I see that quantity, that root 2 over 2, I know that I'm really looking at a reference angle of pi over 4. But it's negative. So where is it? Right? This negative. Where is that telling me it is? In the fourth quadrant, maybe? Or the third quadrant. So I really need this pi over 4 reference angle in either the third or the fourth quadrant. Which then I know, okay, so if I was looking at the third quadrant, that'd really be pi plus pi over 4, or 5 pi over 4. Right? Because we went pi and then the pi over 4 more. Or if I'm looking in the fourth quadrant, it's just pi over 4 less than 2 pi. So I'd have 7 pi over 4 doing my fraction work. So I know x could be those values. That's really bad handwriting. But I want to go back. It said find all solutions. Have I found all solutions?
No.
Why, Joe?
Because there's an infinite amount of solutions.
Why is there an infinite amount of solutions?
Because you can just keep going around the circle.
Right, I could keep going around the circle. And so that means I could hit that 5 pi over 4 spot as many times as I want. I could go a wrap around from there. I could add 2 pi on and get back there. And I can do that as many times as I want. So I'm going to multiply that by n. And same thing here. But again, remember, it's important that we understand what n is. N is an integer. Right? It's a positive or negative whole number because we want to do full rotations from each of those spots. And so there, I have all my solutions. When you look back at this, what was the most important stuff to solving this problem? What were the big decisions that I made as I moved through this that helped the most?